Okay, on 17 through 20, we are given the transformations. We are given the parent function in a graph. We're going to be asked to write the equation for the transformed function and then graph it. So the first thing I'm going to do is I'm going to write the equation. I know this is the cubic function, so f of x is going to equal an x-axis reflection, so that means a negative on the outside, a vertical compression by 1/3. We're going to go to the right 3. Always do the opposite on the inside. Put your cube there because that's your shape, and then down 5. Okay, now we're going to graph this. So what we're going to do is write the parent function table to start with. So this table is 0, 0 in the middle, -1, -1, and 1, 1. That's the parent function. So that's the table for this parent function. And now what we're going to do is we're going to apply these transformations to this parent function and then get the graph. So we're going to do this x-axis reflection and this vertical compression by 1/3. That's this right here. I'm going to do that first. That is a vertical or outside the function. It affects the y's. So we're going to multiply the y's by 1/3. So that's going to give me a new table, xy. The x's are going to stay the same. The y's are going to get multiplied by a negative 1/3. So that makes this one positive 1/3. This is still 0, and this is negative 1/3. Then we're going to go right 3 and down 5. The right 3 affects the x's. So since it's right, we're going to add 3. And since it's down, we're going to subtract 5. This gives me the table that I'm about to graph. Okay, when I add 3 here, 3 plus -1 is 2. 3 plus 0 is 3. 3 plus 1 is 4. -5 plus 1/3 is -4 and 2/3. -5 and 0 is -5. And -5 and -1/3 is -5 and 1/3. Okay, so now this is the table that I graph because I've taken care of all of these transformations. So I'm going to go over 2 and down 4, 2, 3, 4, and 2/3. So almost to 5. Then I'm going to go over to 3, 1, 2, 3, and down 1, 2, 3, 4, 5. And then I'm going to go over to 4 and down 5 and a little bit more. Now you might look at those and think that they look like they're in a straight line, but you know it's this shape, but it's been reflected, so now it's going to be this shape. So we've shifted. So we're coming here, and it doesn't have to be perfect through here. It just has to go through these points right here. Okay, that's good enough for me. Okay, because we've compressed it, which means it's flatter through here. That's why it's flatter right through here because of that compression. Okay, let's look at number 18. We're going to do exactly the same thing. We have an x-axis reflection and a vertical compression. Okay, so let's write the equation first. So this is f of x equals. This is outside, this is outside. A negative outside for the vertical reflection, a vertical compression by 1/2 is on the outside. I know the shape is the absolute value. Then I have to go right 4, so that's -4, and down 3, that's -3. So now we're going to do our tables. The parent function table is -1, 1, 0, 0, 1, 1. We're going to take care of these two first. That means this -1/2 on the outside gets multiplied by the y values. Okay, so my x's are going to stay the same, so that's -1, 0, 1. The y's get multiplied, so -1/2, 0, -1/2. This is x, this is y. Now we're going to take care of the right 4 and down 3. Right 4 means I add 4 to the x because I'm moving it to the right. Down 3 means I subtract 3 from the y's because I'm moving it down. So 4 plus -1 is 3. 4 plus 0 is 4. 4 plus 1 is 5. Negative 3 plus negative 1/2 is negative 3 and 1/2. Negative 3 and 0 is negative 3. Negative 3 and negative 1/2 is negative 3 and 1/2. Now I'm going to graph this table right here. So this is going to be 3, negative 3 and 1/2. About right there. 4, negative 3. 5, negative 3 and 1/2. That's the absolute value function, so it goes just like this.